Bonjour à tous, merci de venir si tôt. We are going to speak in English. I mean, yeah. Who speaks English natively? Okay, so we're going to use English. Welcome everyone, thanks to be here so early to our session. My name is Abderrazak Bouadma. I work in the DevOps teams at Kariba since just a couple of months. I am also the manager, so sorry. And yeah, just a couple of questions before we start. Who is developer? Okay, who does microservices? I mean, as a daily work. And who is DevOps? Yeah. Okay, so we are going to talk about DevOps. Today, we are going to present to you like our experience in moving to microservice world. There is a small part talking about the DevOps part of how microservices are going to run in production, by the way. We are not going to talk about shiny things. It's really the pain. I mean, what are we living every day to move to this microservice world? What is our actual situation? And what will be, hopefully, our roadmap. Are you okay with this subject? Because we're not going to talk about shiny things. It's only reality. Yeah, okay? I'll let Mr. Philippe start the talk. He has a long part of microservice on the dev engineering world. Then I can take the relay after talking about the DevOps part. Okay. Thank you very much.
1, 2, 1, 2. Okay. Hi, everyone. I'm Philippe, and I'm more on the dev side than DevOps. And I will try to give you some reality pains that we faced in Kariba. But before going inside the stack and our road, I will just recap what is Kariba, because I don't know who knows Kariba in the room. Okay. Cheater. But that means nobody knows Kariba. That is normal. Kariba is a fintech founded in 2000 in Paris. And it's basically a company that is doing the active liquidity management. It's all around cash management, risk management, hedge management, a lot of management of cash in Kariba. And to give you some numbers, we'll try to go fast on the numbers. But here is the main numbers. That's why we have an unicorn here, because this year we have Bridgepoint coming in Kariba. And they invested quite a lot, and now we are valued at 1.2 billion, and we have quite nice logos that are here. And here is just to give you an overview of the context, because moving to API platform, we need a context. And in our case, Kariba is spread across different cities, mainly San Diego, Paris, and Minsk. And we have around 200 engineering people, but it's growing fast. Now I think we are reaching the 250. That means we are quite growing fast in 3 different areas with some, we can say that we have some different time zones. And we'll talk about it later. By the way, who was there last year? Okay. And who was there last year and I've seen Jack Sparrow in our talk? Nobody? Okay. That means last year we presented a talk about a route to microservices. And we gave some pains already on it. Today we will try to focus really on the API side, on the microservices. And here is just to recap the target that was in our mind last year. We wanted to move to that basic overview of microservices. And it was just to give you now the context of, okay, we started to think about APIs. But before that, we started thinking about microservices as everyone in the room. We wanted to move, okay, we got a monolith from 2000. I will show you some stack at that time. But we wanted to move to microservices because we had some issues, let's say, with the monolith. And now we are moving to the same design, but more in API way. But why? Here, I just took some press releases about Kariba from last year, just to show you that, okay, we are a fintech, close to banks. That means we are quite safe. Compliance, audits, security is in our world, let's say, top one. We are not doing, like Abderrazak said, shiny things or tech things, because we cannot really fail. And here last year, we got some pressure from the market, and we needed to move fast to the API, to the APIs. And here it's what our sales were showing us daily. They want APIs everywhere. We are running maybe 20, around 30 different components in the stack, and they wanted APIs everywhere. And it was supposed to be delivered yesterday as an eDev. And we were still in the road to microservices. That means we needed to take some decisions. And to do so, we adopted something that is quite old now, but I really like it. Because 20 years ago, it was already in place. And even today, it's not yet adopted by all the people. The DDD approach, domain-driven design. But in our world, we renamed it domain-driven decisions. Why? Because we did a lot of stuff, event storming, we defined some bounded context. And when we work with a lot of different products in different countries with different cultures, to have some ubiquitous language, it's really hard. It takes you a lot of meetings, a lot of discussions to define, okay, what means a cash flow in our company. If you talk to different people, at the end you end with 20 different definitions of a cash flow. But at the end we need to aggregate everything and decide, okay, this is a cash flow for Kariba. And it takes a lot of time. And to do it, we called a company well known in Paris, Arola, to help us to move. Because when we started, it was really hard to convince people to move. And I'm not talking about devs only. But if you talk about on product teams, on sales, marketing, even on the stakeholders in the top of the company, they don't care too much about domain-driven design or such context. They don't really understand what it means behind. That means we needed to make a real training campaign across company, and to put all the people in the same rooms across different countries, and to start brainstorming, thinking about, okay, what is a domain design, or what is our domain per service. And it was really helpful because we started it for microservices first, but we finally found that, okay, a service is not really far from an API, because inside the service you will expose APIs. But again, in Kariba, we got UX and UI teams on the front. For APIs, it was quite hard to say that, okay, we need some kind of UX even for APIs. When you build an API, you build an API for a customer. And the customer needs to enjoy using your API, not fight with documentation, look around, do some tricks on it. That means you need some UX even around APIs. And today is not really common in the market to do such thing. But let's come back to our reality. We did a lot of trainings, DDD, we started defining some services, some domains. But at the end, we have still a big repo, mono repo. I think today you will have a nice talk this afternoon about it. And in our case, the repo is growing daily. As you can see, I just pick up some numbers from Bitbucket. But I think now we are on the top 3 on the size of the repos. And we have more than 100 daily commits. We have 500 active branches. I'm not talking about some feature branch staying for some months, just active branches. And the code base is quite huge, as you can see. Okay, what we decided to do? As usual, okay, we have a big monolith, quite hard now to maintain and implement new features inside. We wanted to split it. With the DDD, it was not easy, but let's say that it was doable to split the big repo in several pieces with Java interfaces first and some Python in some places. But at the end, we end up with several services inside a monolith. And here it's just to give you a picture. I'm not sure who knows about or who is still working on that components. Enterprise, application, archive. Nobody? But it's pretty nice. Because you just package a lot of jars in one JVM, and that's it. It's running. And at that time, we came from 2000. We went through all the versions of GBoss. Now we are running Wildfly 14 on Java 11. But we are still in a monolith at runtime, even if we split our code base in the repos. But at that time, what can you do with such situation? I have a monolith and multi-repositories. What can I do at runtime to make it more, let's say, modular? Do you have some idea about it? No? Who is working with Eclipse as an IDE for Java? Okay. That means you are using it on Eclipse. Eclipse is built on top of it. It's something called OSGI. And I was really fan of it a few years ago. That means you can, even if you are in a mono JVM, you can make it modular. You can have isolated services even at runtime in one JVM with different class loaders. We can pick Felix, for example, for the server side. And it's quite nice. And we tried it. It's nice at the beginning, but after you have some pains. It's quite hard in terms of learning curve. And if you talk to guys going out of university now, they just look at you like, why are you talking about OSGI? Today we have Spring Boot and microservices. We don't need all that complexity. It's not so wrong. But if we come back to our monolith, is it really bad to run a monolith? Now, in Twitter, even in LinkedIn, you have some people talking about going back to monolith. And we think, okay, why? Is it really bad, a monolith? In terms of deployment, it's really easy. You have one JVM to deploy in one server. It's quite okay. In terms of integration in CI, you cannot really have much easier stuff to do. It's just one JVM with multiple jars. API contracts, Java interfaces, even at compile time, you can validate them. Performance is quite hard to compete with a monolith. When you have everything running in one JVM and everything shared with the memory, it's quite hard even with quite nice microservices architecture. It's quite hard to compete. And adding a new service or a new API is just matters of adding a new jar. That means quite easy. That means we start thinking, is a monolith really bad? No, it's not really bad. It's quite simple. It's not complicated at all for dev people. I will let Abderrazak talk a little bit about ops side. But at least on dev side, it's quite easy to go. And I don't know if people remember that picture that we have seen last year. It's just to give you some idea about, okay, you have a monolith. It's here. It's growing every day. It's heavy. It's hard to move. But if you have enough resources, enough devs, you can still move it. Slowly, but it's moving. That means, why not create our first APIs inside the monolith? What do we need? And what was already in place? We already have Spring in the stack. That means, okay, we can take Spring Web. Inside we have REST controllers with REST templates. That means, okay, we can use it and propose JSON messages because all our customers are already using it. That means it's pretty simple to integrate with them. And we have a piece for the documentation, and we took OpenAPI with Swagger implementation. And that's it. We have the ingredients to publish our first APIs. But is it really enough? We did it. We start with 2-3 APIs inside the monolith. We tested. It was working. But is it enough to go prod with that stuff? Not sure. I can say no, it's not enough. And what is missing? All that pieces are still missing in our road. We don't have any authentication in front of the API, no authorizations, no routing, no load balancer, no failovers, no rate limiter. That means it's not really safe to go like that to production. If I sum up all that features, what is it? Anyone got an idea about what is it behind this list of features? I heard something here. Yep. Something really nice. Let's imagine that the car is my customer. The driver inside the car is my customer. And behind the gates, you can find my API. Here, for example, you can go from Mexico to United States. You need to cross the border. And to cross the border, you need to pass the gate. That means you need to identify you. The gate will open or not, depending on the permissions. And after that, you can reach my API. It's almost the same pattern in our case. It's an API gateway. That means we must have this piece in front of our API, or any API. And what if your API is really successful? What happens? If you have quite a lot of people that want to call your API, you face some issues like that. That means you have a lot of traffic coming to the API. If you don't have any gateway to protect you, you will just blow all the system. And you don't want it in prod. And if you are doing payments, you really don't want it. That means you must have the gateway. And here, for example, we can set up quite easily a rate limiter. We'll see after that how. But it's pretty safe. That means you can protect quite easily your gateway. Here, if we come back to remember the target, we are not yet here. We still have some monolith. We have new services around the monolith. And we have the first APIs inside the monolith, because the data is still in the monolith. That means it's easy. We have the gateway that we already started based on the Spring Cloud stack, Spring Cloud Netflix. And we just expose our APIs behind, and we protect them with such gateway. It was nice. And this slide is to show you, okay, it's nice when we rely on open source community. I really like it. And now if you take a look at the gateways, you have a lot of vendors, a lot of projects around. But we took the Spring Cloud stack. It's quite okay, it's quite nice, based on the Netflix. But as you know, in December 2018, Netflix stopped it. They put their stack in freeze maintenance mode, let's say. And we are moving now quite strongly to the Spring Cloud stack. And at Spring 1, few weeks ago, you have a great talk about it, showing, okay, how to migrate from Spring Cloud Netflix stack to the Spring Cloud stack. And it was nice because if you are not in the open source community, you don't have it. Nobody will help you to move. With that open source community around Spring, for example, people are helping you because they face the same issues. They want to get rid of Zool, get rid of Hystrix, get rid of Ribbon. That means you can watch that talk, it's quite nice, showing you how to move from the Spring Cloud Netflix to the Spring Cloud Gateway, for example. We already looked at it, and I think we'll move to it in the next weeks, next months. And here it was a keynote from Spencer at the Spring One, showing all the features of the Spring Cloud Gateway with Webflux. That means it's completely reactive. And on our site, for example, when we did some prototype how to migrate to it, it's pretty simple. It just matters of configuration, and you don't change any code on the application, even if we moved from Zool to Webflux. It was pretty nice to see it. But again, if we come back to our reality, it's still a monolithic application. It's still a monolithic API platform. That means, coming back to that picture, we have our API running in prod. But we started having some issues. If we take the blue point here, unfortunately or fortunately, depending on the people, a lot of people were calling that endpoint. And more, we got some, not really issues, but we could impact the monolith performance because of that endpoint. And we finally decided, okay, we reach a point that we can scale. We can add more monoliths. It's scalable, it's okay, but it's quite expensive. If you run on public clouds, you will see that it's really, really expensive. In our case, it was really expensive. And Abderrazak will show you some numbers after. But we decided, okay, let's take the same approach as microservices. We need to take out these APIs of the monolith. Otherwise, we are not really safe to run it in prod, as the calls are growing quite massively. And we needed to extract them. But what is the big issues that I think you all are facing on microservices world? When you reach that gap and you decide, okay, let's extract a service in a Spring Boot, for example, application. Of course, your application running outside still needs to call the monolith. If you want to retrieve a user or some data from the session, you need the monolith because it was not yet extracted at that time. That means what happens? You need to call the monolith. And here, you face the same issues as everyone running microservices in prod. It's kind of jungle today because, okay, you have plenty of choices. How do you do internal cross-services communication? It's just a nightmare to choose today the good stack fitting your needs. You have REST, of course. You have gRPC, AirSocket. You still have Kariba or Enterprise Java Beans. It's still working. And we have still some in production. Apache Swift, Kafka, RabbitMQ. Depending on the workflow, you need to pick one of them. And you don't really want all the teams choose one of them. Otherwise, you will end up with some big complexity on ops, and we don't need it. And even if you choose one, we choose after some prototypes, we choose Kafka for the queues, we choose gRPC, and we keep some REST endpoints for now. But we are, let's say, moving with these three pieces. You end up with another jungle. Okay, if I'm running a cluster, of course, you're running all clusters in prod. Okay, I need to reach a service from A to B, and the B is a cluster. If I want to reach it, I'm running on Swarm, on Kubernetes, whatever. You have some tools inside that will help you, yes. But you don't have really proxy, nice load balancers. You don't have any mesh. You don't have centralized configuration. That means you need to solve all that pains. And you have a lot of vendors, open source communities around it. And it's quite hard today to pick one. Because some of them are growing, some of them are dying, some of them are merging. That means it's quite hard to choose today which one is the best one for you. We choose some of them, and Abderrazak will show you. And after that, okay, we pick some of them. We were quite happy after some prototypes, and we said, okay, now we need to package it. How to give it to ops or to the CI/CD pipelines? We choose Docker. It was pretty easy choice at that time. And again, it's not a jungle, but close to it. you choose a Docker, but which OS you will put inside your Docker? Alpine, CentOS, CoreOS, Ubuntu, which one? We want a slim image. We want it fast to boot. We want it really safe image because we are a lot of people looking at the audit and securities. That means it's quite hard to choose one. At the end, we choose 2 of them because of our needs, but still, we did it. It's okay. We choose one, and now we need to run it. To run the Dockers today, it's almost, I think, who is running Kubernetes in the room, in prod? And who is running Swarm, Docker Swarm in prod? Still one. We are still running Swarm in prod too, and Kubernetes as well. That means today, if you ask the question, okay, today is de facto Kubernetes. Again, you choose Kubernetes. What it means for the production doesn't mean a lot. Because again, around Kubernetes, you have a lot of vendors, public clouds, managed Kubernetes, not managed Kubernetes, OpenShift, OpenStack. You have a lot of stuff around Kubernetes. Which one to pick? It's quite hard decision to choose. But okay, we choose it. Swarm, Kubernetes, we choose some meshes, but still, logs. We need logs. Again, we choose some pretty obvious stack. With Helk, we need metrics. That out of the box, we have Micrometer in our Spring Boot apps. We have OpenCensus for some gRPC and Python code. We choose Prometheus. But here, at least I like it because you have choices, but you have some kind of standard coming out. Even for the traces, okay, we have Sloot. Based on Brave, we have OpenCensus again, OpenTracing. We have 2, let's say, major competitors, Zipkin and Jaeger. Again, you don't want to run everything in production. You need to choose. And it's quite hard to have some agreement across the teams. And all that pieces means observability. You cannot run anything in prod if you cannot monitor it. Today, we have the OpenTelemetry growing a little bit on CNCF. That means we have OpenTracing, OpenCensus merge inside OpenTelemetry. That means it's every day it's moving. That means you don't know what will happen tomorrow. That means today you will take a decision that maybe will go live in 3-6 months, and maybe will die in 1 year. That means we are going a little bit to the JavaScript world, and we need to move fast and change pieces really fast, because we don't know how the community will move. And here we have some vendors, quite nice for the observability, and something that Abderrazak will also show you, it's Datadog. Quite nice. What happens after that? I think you will all agree on that. It's complicated. Even if you want to publish a simple REST endpoint inside your company, but you need to do it in the right way, it's really complicated. You will face the same issues as with microservices, and you don't have really out-of-the-box solutions to solve all your problems today. I will just finish my part with such concepts that are quite old today from Martin Fowler, but still up to date. Okay, we want to break silos. We want to build autonomous teams. In theory, it's nice. In reality, it's really hard. That means you need to convince all the company across all the countries to say, okay, we need to do it. It will be nice. But it will cost a lot of energy and a lot of cash. And it's not really the reality. You never see it in companies running in prod with a lot of products. It's not really happening often, because at the end we'll end up with different stacks. And you can see at Netflix, they did it for years. Now they are moving back a little bit from that, because at the end you end up with maybe 10 languages. You need gRPC because you have polyglot services, and you have a lot of overhead around it. That's why I like this approach. We try to do the same, but with some alignment between the teams. That means it's like a car. you have a lot of teams around the car, autonomous teams, but they must be aligned. Because at the end, you will run, as a company, the product will run in prod, and all the products need to communicate each other. That means we need some alignment at some point. I don't really like the architect teams or whatever. I like that all the teams should have some agreement or consensus to adopt some cross-services communication and to reach production in a good shape. And I think I will let now Abderrazak show you the reality on the Ops side. After that, all the route did on the dev side.
Okay. Thank you, Philippe.
Welcome.
So my part is going to be focused on the DevOps side, saying some SRE. We started some SRE approaches in our team. The idea, I'm going to introduce you to like a bird view of the infrastructure, the actual infrastructure, the actual process that we have. And on the second part of my presentation, I'm going to to project you the roadmap, more or less. So our actual infrastructure is, we have 2 data centers, one in the US and one in the Paris physical. I mean, these are our own data centers. Of course, each data center has its backup. So they are physical, so this is what we call on-premises. We also deploy the application on AWS on these regions. Yeah, there is some constraints. We have China Great Firewall, so we have to deal with this. We have, of course, data regulation, the GDPR in Europe, some bunch of flows of data privacy in the US, and of course in China. So we have these kind of constraints. So this is like, in general, when an ops want to connect to our one of our data centers, we did a lift and shift of the on-prem to AWS, which means that it looks like this. We didn't a true cloud design for AWS. Yes, we're working on it, but it's coming in a couple of months. We're trying to create like a standard treasury infrastructure in the cloud. This is like another task that we're working on it. So he has only access through a VPN, through a Bayesian. Then each data center is sliced with a different environment. We have 4 of them. Prototyping for developers, sandbox. It's like a production for our sales. They do demos on it. We have pre-production, of course, and of course the production there where we make money. So this is an overview of one environment. The green rectangles represent like a general view of what is a VPC isolation. So that each part is a VPC. It's a virtual private network. So we have like 2 bunch of them, the front and the back VPCs, obvious. We have, of course, segregated the data within another VPC. We have storage. We still have like old storage fashion like FTP, etc. Bank systems are still working on this, though we have to provide this protocols. And everything is managed. We use Chef, actually, to manage all the like state of an environment. So we have on each VM a Chef client that discusses with a Chef server. Who uses Chef in the? Okay, there's only one. So where to? So the idea is Chef is keeping the state of the environment, whether on sandbox, pre-prod, production. All environments are managed with the same thing. So on Prem, we're running VMware, vSphere. We're running to the latest version 6.5, I think. And we have the same thing on AWS. So this, I'm going to explain you our build process. So engineering teams provide code. The idea is, hey, we have this piece of code, let it run somewhere. Okay, this is the main request they do. So they push that code. When they push that code, so we have Jenkins that will start some pipelines depending on the project. We are multi Git repository, so depend on the team. So each piece will be built like we're going to run tests and some build stuff. I don't want to dig in the details here. And the rectangle over, this is like our custom thing to keep the state of which version is going to run with which version. We have to keep a certain consistency between the versions, because we cannot just upgrade the version like this. We have to keep the version. To keep this state, we have another Jenkins that will start just after the first one. We'll start these pipelines. The pipelines will do smoke, user acceptance, and regression tests. This will validate that we can now update the state. The idea behind this slide is easy. I mean, it's simple. We cannot afford upgrades to a new version of like libraries. We cannot just switch to a new version of I don't know which library. We have to keep this, and it takes a lot of time. All these Jenkins are running in AWS, and it costs a lot because we have teams in the US and in France. So at 24 hours, they work 24 hours all the day. And I mean, it really costs a lot on AWS. So you have to keep this in mind. At the end of the Jenkins process, we use Rendeck for deployment. So the Rendeck, it will be, it's all Chef also. I didn't just put Chef everywhere, but everything is maintained by Chef. So a Rendeck jobs will start based on the script that we put there, and we will going to deploy automatically all this application on our prototyping environment. We give them like Leo or Gemini names. We're still in the pet approach. We're not yet on the cattle approach of environments. Okay. The idea is, as I said, our Jenkins are organized by a master, and we have a bunch of slaves, and they are all running on AWS, but they are running in VMs. Okay, VMs works well. I mean, if everything is correctly configured, they work. But the problem is that they cost a lot because they are on all the day. So we've searched another way to replace this. So we decided to use Amazon EKS, which is a Kubernetes implementation on Amazon, to have built-in pods. So this will help like reduce the cost, because whenever these pods are not used, they will be automatically destroyed, and the nodes are going to be also scale out depending on the load of building the application. So by the way, we're using Helm for deployment the application on Amazon EKS. We use, I mean, it's our KubeSpray custom deployment of EKS. We don't use EKS directly. We use KubeSpray. Who knows KubeSpray? KubeSpray is an Ansible abstraction over kubeadmin. It's just a bunch of Ansible scripts that runs there that help you to create your Kubernetes cluster. And OPA, which is Open Policy Agent, I think, which help us, for example, to put some policy. One policy is to not provide any public load balancer, for example, because we're on Amazon EKS. So we have to really be sure that this is not public. It's only running in our environment. So we build, so we have everything running ready. We build the binaries. We use Artifactory for this. Whether jars, whether Docker images, everything is on Artifactory. So we have to deploy it. To deploy it, we have to run we have to follow all this process. I'm not going to explain it. Just the idea is it's a very long process, because we have a deployment, a release manager who will decide which version is going to where. Because depends on our customers, it happens that we can deploy different version of the same application, even in production, because we haven't yet like standardized the deployment on all our infrastructure. This is a legacy, so we have to deal with it. Okay. So it happens that in the middle of this process, we find a bug, so we restart from the beginning, and it takes time. And it happens that even this process goes several times a day. There is manual, there is automatic part, but there is manual part. We have to deal with some, let's say, manual issues. We haven't yet automated. For example, our run deck, we're running with a problem with the WinRM plugin. WinRM plugin helps Rendeck to run scripts on Windows machine. So it's always Windows that create the problem, but this is another story. And this WinRM, we have to update it because we haven't yet updated Rendeck. But we cannot update Rendeck because we're not yet ready to update our script. So, it's like a sequence. Okay, until now, for identity, for services, for example, we use LDAP. LDAP, okay, it works, but you need an expert on it. It's very hard to maintain. It's very hard to scale also. And it runs on Windows. So the day we want to containerize, I don't know how to say it, our identity process, we have to deal with Windows. But our idea is to get rid of it. I'll show you next. We have also to log. So all logs now are pushed through using FileBit and Logstash. We push them all on ALK. Our ALK is running on Kubernetes clusters. But the problem is that makes a lot of data to handle. We have too much data, and we have some constraints. For example, keep the data at least for 10 years. So we have to keep it on hot for 3 months and on cold for 10 years. This is, legal. We cannot just throw the logs like this. We have to keep them because whatever issue that we are going to face in the future, customer could claim, hey, I need the logs for like 2019. Suppose we're on 2029. So they need to have access to this. It's legal. We cannot just throw them. And it costs a lot on the network because we have to move all the data on the ELK on Amazon, so it costs a lot also. Telemetry. So telemetry, we're not, actually we use all these tools. Ganglia, it's like an old stuff. CheckMK, we upgraded to the version 2, but it's still not really good. We use Thousand Eyes for service accessibility. And I don't know if you know it, PagerDuty, it's something that will call you on your phone to tell you we have an incident, we have something wrong running on the platform. And we started to use CloudWatch also. CloudWatch is something on AWS. For service discovery, we developed something. I'm not going to explain it all, but the idea is we have Swarm in production. We have services running in Swarm. And we have like what we call out of process, the process of Swarm, like a piece of code outside. This piece of code want to have access to this services in the Swarm cluster. Imagine it's Kubernetes also, it works. So we provided a solution, it's an ILB, it's an internal load balancer based on the use of HA proxy and Keep Alive. You can find this, I can talk with you if you want after the session. And the state of all this, for example, hey, there is a new service, I will deploy a new service. So deploying the service will be done with Chef, and Chef will keep the state, the update of the new services on the HA proxy, on the configuration. So it's custom thing. It works. It's like an HA approach, but it's still custom. We're not in the standard yet. And business continuity. Business continuity means that customers in front, they need, we promised them an SLO, an SLA of 99.9. So we have to keep 24 hours, 7 days service up. But of course, something could happen. So the DC may run in fire, etc. So we have to replace, to give them access to another environment, keeping the data and the state of their work. It's pretty hard also to do this. So this is our roadmap. So do you remember this? The red one is a JavaScript because they always follow the light. New stuff, shiny things. Yeah, you don't have because we can run in problems. So we can have some surprises. So we have to deal with this. This is actually the CNCF like ecosystem, it's huge. A lot of things. You have to hire people. This is for us? Okay. 30 seconds. You have to deal with all this technology, all the problems that will bring, and you have, of course, to hire people that knows how to use all these technologies. Engineering asking us to bring these services on the cloud also. So the idea is our infrastructure is going to be, we are on the roadmap to update everything and to refresh everything, but we will still have this on-prem based on VMware somewhere. We'll keep it for a couple of years. So you have to keep in mind that we cannot just get rid of the legacy just by turning on a Kubernetes cluster. Turning on a Kubernetes cluster means turning on new problems, so you have to deal with. The build, we have to standardize it, so we have kind of custom build process that we have to get rid of it. Identity, we're trying to implement these solutions for API, essentially. And for telemetry, we're not getting rid of the actual tools because we don't know. I mean, what will happen if we just delete them? We don't know. So we are going to move to new solution, but we have to keep this kind of old stuff. We cannot just get rid of them like this. Service discovery, we're trying to start to see how we can put console in our infrastructure. And conclusion. So it looks like, for conclusion, quickly, in my opinion, there is no conclusion. Because it depends on the context of each one. We have to hire people, we have to organize people, scale the teams also. Before scaling the system, we have also to scale the team, hire the good people, etc. So for me, the most important thing, I mean, the thing that you have to keep in mind is there is no like a solution graved in the rock. Each context is special, but you are going to run with this kind of problems, everyone. So just be sure that you will run in these issues. Kubernetes is not solution. It's part of the solution. That's it. Thank you very much. If you have any questions, we can take them or we can discuss in the booth if you want. You're welcome. Thank you very much again.